By the way, my company is Information Technology and Data Management Center under the Ministry of Economy of Azerbaijan. We must collect and update some building footprints from satellite imagery or from land grounds. That's why our company got tasks. All of them solve about two options. One option is manual digitizing. Second option is we must use artificial intelligence. We thought about the one option is time consuming and operator manual digitize all of building footprints from the satellite imagery. This is time consuming process. Also, we have some limited times. That's why our company or our team decides that we must use GeoAI. Also, we must create or we must train our own model, GeoAI model. Our first step is prepared data. What is prepared data? Also, there follow Esri workflow. Esri company gives us good documentation and some presentation for this instruction. We must firstly collect and correlate all of satellite imagery, all of the process imagery. After this process, we create label features and also we give some periodic assurance for this data. Implementation of what is expert training data? In this situation, I note that Esri company also give us two options. One option is we must use ArcGIS ARC. Second option is we must use ArcGIS Pro Tools. In this situation, we use ArcGIS Pro Tools because we want to solve all of process visually. Export training data tools. What is export training data? We must export all of image masks or images from satellite imagery using our collected data. You can see here or have some footprints, some screenshots, ArcGIS tools. First, we must import our satellite imagery. Next time, we add here our collected data with this data values, with the different GIS data, RGB values, this metadata. Next, we must add here our output image format. You can choose here GPH, PNG, and other formats. We choose here GPH format. Also, it's most useful thing we must add here our tile size. Our tiles, since we choose here 256 tiles, because we choose this size is useful for object detection. Our model can understand this training process very good. After you can see here, we add here some rotation angle, 90 degrees. Why we add here rotation angle, I will talk about after this process. Rotation angle is some functionality. The company gives us some functionality. This is the augmentation functions. All of artificial intelligence learners, trainers use these functions. In this, I will talk about this, why I add this function, why I add this customized options here. Now, our expert training inputs is ready. We must export, we must run these training models. You can see as below here, we have output formats. When we click run button, end of the process, we get our image, our labels, and our metadata format, JSON and JSON. I make some note here. If you want to train, if you want to export our data using ArcGIS Pro or ArcGIS Alpha, you must use high parameters, local machines or virtual machines, because expert data training process, our machine use only CPU. If your CPU high, these parameters, this period with little times will generate all process. Okay, our second steps we have image and labels data. We pass third steps. Our third step is model training process. Model training process as the company also give us some workflow. What's this workflow? We must configure in these sections our models, our data, learning rate. We must find first the learning rate. Learning rate is important since we train our model. Next is we must configure our model batch size and epoch size. When you train with deep learning or AI models, you must choose best performance GPU environment. Model training process, we add 100 epoch counts. What is epoch counts? Epoch counts is give us one propagation and back propagation process names. Also, we add our codes. Early stoppings. What is early stopping? I try to explain to you very basically. Tell our machines, our model architecture. If you understand that you learn all process, stop this process. Don't take this long term. That's why our model training model learn 45 epochs. This training period exactly take 20 hours. I note that we use that NVIDIA RTX 39 GPU. This GPU it depends on your data, depends on your problem solving process. If your computer machines, if your data is huge, you can solve your problems. Don't waste your times. Also, we use here 128 gigabyte RAM. Okay, now what we have some training model instruction. We must train our model process. After this process, I will show you we training our model. And also you can see here our model's loss curve and ground truth comparison. Our model loss curve shows that how our model's training process passes. We saw that our model training process passes is very good. You can see here train and validation graphs, also epoch counts. Also you can see here ground truth and prediction results. Our last step is model prediction. In these times, we demonstrate and we show our model result. Now we see. In this station, as company gives us also two options. One option is RTX RP, second option is RTX Pro Tools. In this process, we use RTX Pro Tools because we want to see all processes visually. Firstly, we must add here our satellite imagery. It will be GeoTIFF or map service format. We use here map image service format, satellite imagery. Also, we must add here our model ERPK files. ERPK files is Esri based models files. If someone use others model architecture, someone save their models 30 centimeters max down Airbus satellite imagery, but it's successful predicted good footprints on 10 centimeters over Baca and Upshur, Pennsylvania. This is very good result because we trained our models 30 centimeters satellite imagery, but our model give us good predict results over the 10 centimeters over the photos. You can see all processes here with you. Now I will show you with your configuration of prediction result on different mixed sessions. In our company, we have some web applications for end users. We add this web application satellite imagery and all predict results. End user can see this process very visually. This satellite imagery 10 centimeters orthophoto. Now you can see our model predict results. Our model how predict all of the footprints very good, very easily. Now my colleague prepares some video presentation. You can see our process. We prepare all of different data and we prepare some map series and add these applications for end user. You can see that this is some task-based process. We don't show all of countries satellite imagery. Now my colleagues opens different satellite imagery. This satellite imagery resolution is 30 centimeter satellite imagery. Now you can see here all of buildings detected very good results. We think that. Why we think that all models results? Very because we solve all problems with this building footprint models. We don't waste any time. We don't make other solutions. We use all the GIS tools. We train our models. Our operators don't make any manual digitizing. We only digitize all of buildings using GIS, and we think that we solve all problems. Okay, what is the result? All model accuracy is over 800%. In next times, in future, we want to improve all models, but this time, this model is enough for us. In future, we think that we must improve these models and we must prepare or change detection models for finding new buildings and other buildings. For this process, we use 30 centimeter maximum error per satellite imagery. I thought that also we created 10 centimeter option on the 4. This is our models results. In this process, what is challenge and